All right, now this example is the third type of hypothesis test that you're going to be looking for here. And this is going to be a hypothesis test that's around a sample proportion, a single sample proportion. So a sleepwalking study found that in a random sample of 19,136 American adults, 29.2% sleepwalked. If a news reporter stated fewer than 30% of adults have sleepwalked, the question is, would that statement be justified given a 95% confidence level? So again, answer this question by comparing critical value to test statistic and significance level versus p-value. So now in our answer, we're going to be using different functions. Texas Instruments, we're going to be using the one proportion z-test. And on the NumWorks calculator, we're going to do a one sample proportion z-test. All right, so we'll just go through our 5 steps. Step 1 is let's look at our given information. So a sleepwalking study found that in a random sample of 19,136 American adults, so that's our sample size, 19,136. 29.2% sleepwalked. Okay, so this 29.2% is related to our sample. So this is a sample proportion, so p prime. So that's 0.292. All right. Let's see here. If a news reporter stated fewer than 30% of adults have sleepwalked, okay, so 30% of adults, okay, that's kind of indicating a population. And remember, we use the letter P without a hat or a prime, an apostrophe, to signify a population proportion. So let's see, fewer than 30%. So we're saying that the population proportion is fewer than 30%. And that is our original claim. All right. Now, so one thing that let's see, will we need that for our calculator? I don't think we're going to need it for the calculator function, but it's going to be good just to refresh our memories since we're dealing with proportions. We have p prime is equal to 2.92. And remember that this is the proportion of successes. And q prime is equal to the proportion of failures. And that's 1 minus p prime. All right, so q prime in this case, wait a minute. Actually, it shouldn't be p prime and q prime I should be calculating. It should be p and q. I'm sorry. Let's do that. I mean, what I'm telling you wasn't wrong for sample proportion of successes and failures. But the value that we would use if we were manually calculating things would be population. Okay. So let me change this to 30%. Okay, so the proportion of successes with the population is 30%. And so the proportion of failures with the population is then going to be 70%. So 1 minus 0.30. All right. But the one thing that we will need to calculate, for the calculator function x, okay, so remember p prime is equal to the number of successes over the sample size. And we know that P prime is 0.292, and we know that the sample size is 19,136, but we don't know how many successes that ends up being. So what we need to do is to solve for x, this little mini algebra equation. So if we just multiply both sides by 19,136, then the 19,136 on the right-hand side will cancel out, and that gives us a number of successes of 5,588. Okay, so let's just kind of put that aside for now. And let's move on to step 2, which is to set up our null and alternate hypotheses. So the original claim was this. So we've got p less than 0.3. That is our original claim. And the complement of that is going to be greater than or equal to. And so because it says equal to, that's going to be our null. So the other one has to be our alternate. And the alternate tells us what kind of distribution we're talking about. So this looks like an arrow pointed to the left. So we're going to be dealing with a left-tailed distribution. And that brings up another point I forgot to point out in step 1, is the fact that we're dealing with proportions, right? We're dealing with proportions. This means we're going to be looking at a normal distribution, okay? So when we create this left-tailed distribution, it's going to be a normal distribution. So we'll be dealing with z-scores, okay? Okay, sorry I didn't point that out a little sooner. Okay, so now we can move on to step 3. And this is to calculate our test statistic and our p-value. Now, if we were going to calculate this manually, our test statistic now is a little different. It's p prime minus p all over square root of p times q divided by n. All right, and this is the reason why I noticed my error earlier, is that you'll notice that this equation down here, requires P and Q. And so that's what I was actually trying to calculate up here. So if we wanted to manually calculate this test statistic, this is the values we would use. We wouldn't use P prime, we would use P, our population proportion, because that's what this equation requires. All right. But we're going to be using the calculator for our values here. So we're going to be doing a 1 proportion z-test, and the proportion value that we're looking at is 0.30. We calculated the number of successes to be 5,588 out of a sample size of 19,136, and our alternate hypothesis is p less than 0.3, so it's going to be that option right there. Let's see, the NumWorks calculator, okay, so p is equal to 0.30, and it's going to be less than 0.30, so it's going to be that option right there. The number of successes is 5,588 with a total sample size of 19,136 and a significance level of 0.05. All right, so let's go ahead and find those, because that's going to give us our test statistic and our p-value that we need. So let's do the numworks first. So we're in the distributions app, Jason, and we want to go to the inference app now. And let me back out of this because now we're in the students T. Let's back out. All right. So now we're doing a test, okay, but it's not a single mean test. It's a one proportion test. Okay, and so our proportion here is 0.3. And our alternate hypothesis is less than. So we'll hit next. Okay, the number of successes was 5,588 and a sample size of, let's see, what was it, 19,136? Significance level of 5%. So we'll hit next. Okay, so that's giving us our test statistic, negative 2.410, and a p-value of 0.0080. Okay. So let's go to now the Texas Instruments. Clear this. Okay, we're going to hit Stat, go to Tests. Now what we want is we want a one proportion, single proportion Z test. Okay, so make sure you're using this one. Not a two proportion Z test, but a one proportion Z test because we have one sample proportion. Okay, this value is 0.3 with 5,588 successes out of 19,136 sample size. And it looks like it's already set to the population proportion less than 0.3. That's our alternate hypothesis, so that looks right. So we'll hit calculate. Okay, we get negative 2.410394 with a p value of 0.00796,764. Yep, that looks right. Okay, so let's go ahead and write those values down. So we have negative 2. I already forgot what it was. 2.410. 2.410 with a p-value of 0.00. I'm just going to put 008. All right. So let's move on to the next page, and I will rewrite those values here. So I have them at the ready. So our test statistic was negative 2.410, and our p-value was 0.008. Okay. So step 4 is to set up our distribution. Okay, so this is going to be a normal distribution. So again, I've given you plenty of room to draw these sketches. It's left-tailed, so I'm going to have my critical value and the boundary here on the left. Okay, this area in the tail, that is our significance level, which is 0.05. Confidence level of 0.95. The region over the significance level is our reject the null region. Everything else is fail to reject the null. Okay, a z-score of 0 is the center. All right, now we just have to figure out this critical value. So to convert this area into a value on a number line, we're going to use our inverse distribution function. Okay, so let's quit out of this, Go to the distribution. We'll go to inverse norm. Okay, an area of 0.05. Mean of 0, standard deviation of 1. Area to the left, I'll take it. Paste and enter, we get negative 1.645. Okay, let's just do that really quick with the numworks calculator. So I'll just hit home, go to distributions. Okay, I'm in the student's t distribution, so I've got to back out and come up to the normal distribution here. Mean of 0, standard deviation of 1. Area on the left with an area of 0.05. Negative 1.645. Okay, so this is going to give us a negative z critical value of negative 1.645. Okay, negative 1.645. So now that we have that, let's take a look at our test statistic. So that's negative 2.41. So that's actually going to be somewhere out here. So our z test statistic is larger in the negative sense, negative 2.410. And so if we go up from that, that's clearly going to indicate we're going to reject the null. And the area here in the tail, that is our p-value, and our p-value is 0.008. So what you can see is that the p-value is smaller, therefore reject the nuller. Okay, so let's go to step 5. So if p is smaller, then you reject the nuller. So we're going to be rejecting the null hypothesis, and the alternate hypothesis was our original claim. And before I forget, let me put my information here on the side. There we go. And let's come down. And let's start with formulating our conclusion. Come on down. Okay. So reject the null. Alternate is our original claim. That's going to point to this outcome right here. So we'll just start writing it. There is sufficient evidence to support the claim that significantly fewer than 30% of adults have sleepwalked, and that's going to be with a 95% confidence level. There we go. No. And there is our answer. Okay, so this was the third type of scenario where we're dealing with proportions now. And when you're dealing with proportions, you use a normal distribution. So you have to use inverse norm here. And because we're dealing with proportions, you've got a different proportion test you need to run on your calculator. All right, so let me know if you have any questions.